What if I told you your next glass of water may have started as sewage? It might sound unbelievable, perhaps even a little unsettling. But in an era defined by increasing environmental challenges and a growing global population, the way we think about and manage our water resources is undergoing a radical transformation. We're pushing the boundaries of innovation to ensure a sustainable future for generations to come. Sounds gross, but it's true, and pretty amazing. The technology that allows us to transform wastewater into a safe and usable resource is a testament to human ingenuity and our commitment to finding solutions to pressing global issues. It's a process that involves multiple stages of purification and rigorous testing, ensuring that the end product meets the highest standards of safety and quality. These days, water is precious. The reality of climate change and its impact on water availability is becoming increasingly evident. Droughts are becoming more frequent and severe, placing immense strain on communities and ecosystems alike. This scarcity underscores the urgent need for innovative solutions that can help us conserve and maximize the use of this vital resource. In places like Wichita Falls, Texas, severe droughts forced cities to get creative and recycle their wastewater. Faced with dwindling water supplies, the city embraced the concept of water recycling as a viable and sustainable alternative. This bold decision not only helped them weather the drought but also set a precedent for other communities facing similar challenges. It demonstrated the potential of wastewater recycling to augment traditional water sources and enhance water security. But how does sewage actually become safe to reuse? The transformation of wastewater into a safe and usable resource is a complex process that involves multiple stages of treatment. Each stage is designed to remove specific contaminants and impurities, ensuring that the final product meets stringent quality standards. From the initial removal of solids to advanced purification techniques, every step is carefully monitored and controlled. First, modern treatment plants scrub out solids and most pollutants. This initial stage of treatment involves the removal of large debris, grit, and other solid materials from the wastewater. Screens and settling tanks are used to separate these materials, which are then disposed of properly. This process not only protects the downstream treatment processes, but also reduces the overall load of pollutants that need to be removed. What happens next depends on how clean the water needs to be. The level of treatment required depends on the intended use of the recycled water. For non-potable applications such as irrigation or industrial cooling, a lower level of treatment may be sufficient. However, for potable reuse, which involves using recycled water for drinking, a much more rigorous and advanced treatment process is necessary. For things like watering crops or cooling power plants, treated water goes through purple pipes, so everyone knows it's not for drinking. The use of purple pipes serves as a clear visual indicator that the water is not intended for human consumption. This color-coding system helps prevent accidental cross-contamination and ensures that the recycled water is used only for its designated purposes. It's a simple, yet effective way to safeguard public health and maintain the integrity of the water distribution system. This is called non-potable reuse. Non-potable reuse is a widely adopted practice that helps conserve valuable freshwater resources. By using recycled water for applications that don't require drinking water quality, we can reduce the demand on our rivers, lakes, and aquifers. This approach not only helps protect our environment but also enhances the sustainability of our water supply. Now, turning sewage into drinking water? That's a bigger feat. The prospect of transforming wastewater into a safe and palatable source of drinking water represents a significant advancement in water treatment technology. It requires a multi-barrier approach that combines advanced purification techniques with rigorous monitoring and quality control measures. The goal is to produce water that meets or exceeds all applicable drinking water standards. There are two main ways: indirect and direct potable reuse. Both indirect and direct potable reuse offer viable pathways for augmenting our drinking water supplies. Each approach has its own set of advantages and challenges, and the choice between them depends on a variety of factors, including local regulations, environmental conditions, and public acceptance. Indirect means the treated water is sent to rivers, lakes, or underground, where nature helps clean it even more before it's pulled back in for final treatment. This natural buffer provides an additional layer of purification, as the water percolates through soil and rock, removing any remaining contaminants. The time spent in the environment also allows for natural processes to break down organic matter and further improve water quality. Direct reuse skips the natural step, sending treated water straight to advanced purification systems. This approach relies on a series of sophisticated technologies such as reverse osmosis, advanced oxidation, and ultraviolet disinfection to remove virtually all contaminants from the water. The resulting water is of exceptionally high quality, often exceeding the standards for conventional drinking water. This demands super advanced tech and constant monitoring with no margin for error. The advanced technology used in direct potable reuse requires meticulous operation and maintenance. Continuous monitoring of water quality is essential to ensure that the treatment processes are functioning effectively, and that the water meets all safety standards. Any deviation from the norm triggers immediate corrective action. Of course, people worry. No one likes the idea of toilet to tap. The term toilet to tap can evoke negative emotions and create resistance to the idea of potable water reuse. Addressing these concerns requires open communication, education, and transparency. It's important to emphasize the rigorous treatment processes and the multiple barriers that are in place to ensure water safety. But with layers of safety, transparency, and public trust, cities like Wichita Falls have turned nearly 2 billion gallons of wastewater into crystal-clear drinking water with zero safety issues. This success story demonstrates the potential of water recycling to provide a safe and reliable source of drinking water, even in the face of severe drought. It serves as an inspiration for other communities looking to enhance their water security and resilience. So next time you take a sip, remember, technology and smart thinking are giving us a second chance at every drop. By embracing innovation and adopting sustainable water management practices, we can ensure that future generations have access to this precious resource. The journey towards a water-secure future requires a collective effort involving governments, industries, and individuals working together to conserve, protect, and reuse our water resources.